These tools are newer tools that have just come out in the last few months. Rocprof-tracedecoder is included in the ROCm 7.0 release. But let's first go over where they fit in the overall scheme of profilers. So Rocprof v3, we get the basic profiling and hardware counters. Rocprof-sys, we get a system level view, including CPU, MPI, OpenMP, many other things in the Rocprof-sys profile. And it primarily gives us that timeline view of what's happening. Rocprof Compute, you can dive down into the performance of individual GPU kernels. But what's missing is the tool that looks at the performance within a kernel. We can see the overall stats for a kernel, but we can't see the lines of code within the kernel. There's been some internal tools for that, but they were not of sufficient quality to release. So recently, they put considerable effort to create a tool that they could make public. And so we want to know what lines of code are taking what resources, what time, what's causing the stalls, what is consuming LDS memory and vector general purpose registers. So to do that, we have a viewer called Rocprof Compute Viewer that's going to give us a high-level view of the kernel. So in this, this is sort of an overview of it. Over on the right, we can see the lines of code that are generated. And you can see lines of code and the assembler that is created from those lines of code. So you can click on the line of code and see the assembler, or click on the assembler and see what line of code it is. The bar chart, the bars here show the consumption of resources. So we can see what is consuming LDS, vector registers, and that gives you a quick overview of what you have to pay attention to inside the kernel. Up on the top is a timeline view of what's happening on the compute units. And so we can see LDS usage, stalls, and there is a legend that goes with it that will show you what each of those colors means. Over on the left, we can see an overall summary of the kernel and what kind of thing is what the major types of activity that are occurring in the kernel. So here we immediately see that it's using so we can see that we're using MFMAs, which are the matrix units. So this is a GEM kernel, matrix multiply kernel. So it's using quite a bit of that. We can see vector arithmetic logic unit, LDS usage, and these same colors also apply to these other plots. We can get timeline views of what's going on during the execution of that kernel. So in this plot, we're seeing the stalls are in the red. So that's telling us that we're doing okay on stalls, but there's also waits, which are in the yellow. We can see the consumption of resources and the hotspots that are occurring, and also the occupancy timeline. So that all gives you a pretty good idea what's happening in the kernel over the time the kernel's executing. So let's dive into this a little bit deeper. So look at this instructions view in the Rocprof Compute Viewer. Lines of code are on the right and the assembler is on the left. We've seen some of this with Godbolt and other tools, but it's very convenient to see it all in one place. We're getting here the hit count and latency. So this might help you with the latency question that we had earlier about the memory access on the MI300A. When you click on a line of code, it's going to realign the start of that upper trace, timeline trace. And the color coding, we see the summary here up in the upper right that I clipped out and put up there. Some of the detail of what each of those colors mean is not always clear, and I can expect that there will be more information on some of those as this tool gets into production more. So how do we use this trace decoder? There's two parts. You use the trace decoder to generate the data, then you copy it to your system and view it. So here we're seeing that we load the Rock Profiler SDK where all of that is built onto on AAC6, and we're going to run the vector add. The key things you got to add is this --ATT and -ATT activity options to the command line. And then we're going to define where the data is going to go. You do have to get the source code lines is a little tricky. You have to compile debug and include these flags. So once we get the data out from doing a run, we can tar up that file and move it to our own local system. And on our local system, there is a Windows installer that will install the viewer. On other systems, like a Mac or a Linux system, you have to build that viewer from source. At least right now. So here's the Rocprof Compute Viewer. We're going to untar that data that we just collected, and we're going to start up that viewer in our local system. We can use the import at the top left here and import that data. When I was using this was a pre-release version on 6.4.1 and 6.4.3 of Rockem, and sometimes the source code would show up on an example and sometimes it wouldn't. This vector add, it does show up, but this bar charts here are very, very short, so you can hardly see anything. Here's our summary view for that kernel. And we see we don't have the matrix unit involved in this kernel, but we do see vector arithmetic usage and other stalls here, and sure what each of those bars is. So we see a lot of stalls in here, and so what that's telling us is this one's waiting on memory. Because it's just a vector add, it has to wait for memory loads, and that's a big percentage of the kernel. So we can conclude from this that we're memory bandwidth bound, and we could be doing a lot more compute in the kernel. Let's look at the wave state timeline to understand a little bit more of what is happening here. So in this wave state, we see that at the start of the kernel, we have a lot of stalls. Once the data is loaded, it's it's performing pretty well, but there's not a lot of compute here. So there's not a lot of green, just because it's a fairly lightweight kernel. Here we've got a hotspot timeline. So we see this initial memory request here. We're waiting on that memory, and then all of a sudden we see this compute happening. Now we're seeing it by compute unit, and this is sort of interesting. You see sort of bursts of activity here. We see this initial wait on memory, and then we see bursts of activity. And the GPU is so fast that it finishes its work and is looking for more work to do. So Rocprof Compute Viewer, you can basically download and use a sort of a Windows installer for that. TraceDecoder is kind of tricky, and I would actually recommend that if you're going to try that, use ROCm 7.0 release. I did get it to install on 6.4, but it was kind of tricky to get that to work. I'm going to skip the instructions for 6.4. This does use a binary package called AQL profile. So that just gets copied over to the system. Now, Omnistat is another package that was developed for some customers that wanted to see a system level view of what was going on. So this is for system managers of the compute resources. But it's also been used by Livermore for to get overall statistics for an application. And what it gets out are a whole set of metrics, so you can monitor things like GPU temperature, frequency, see if there's any issues on the system. And the idea here is that we would have a monitoring system which would flag something for the attention of issues with the system, such as something running too hot, or that the GPU is in a state that it's not able to do any work. So here's some sample view of what is coming out of this. So we can see here each of the cards in the system, the memory utilization. That gives us an idea if we've got one of the GPUs not performing correctly. So it's a research project that has been distributed to some customers, and you can download this from the Rocm GitHub site, and the online documentation is at github.io/Omnistat. We have questions on any of the community tools or these newer tools. Any interest in them? I think some of these are deeper dives than the average application might want to get into. But if you're really trying to dive down and find out what's going on in a kernel, it can be, especially a long kernel, it may be very useful. Okay, we're running a little ahead of schedule. I'm going to suggest we take a 10-minute break here, and then we're going to go into the system administration. I think we may spend more time on that. I heard some interest in some of the issues of installing software, and we want to go over that and give you all the tools that may be helpful for some of the issues you're having.
That sounds good. So see you at 2:20?
2:20.
Okay.